Hello students, welcome to Unacademy. How are you? So I welcome you all in this beautiful session and beautiful series of fluid mechanics, and today we are going to talk about few more very important properties, and that is surface tension and capillarity, right? So I hope you people are doing absolutely fine in your life. Your preparation is going perfectly fine. So let me introduce myself first. That is I'm Shivam Dixit. I did my MTech from NIT Calicut in thermal science. After that, I got selected in many PSUs including IOCL, and from last 9 years I am teaching for GATE and ESE. So I have guided more than 50,000 students up to now, and many of my students secured a single digit and double digit rank. So this is all about me, but one bad news is there that today in my area, electricity problem is there. So from last few hours there is no electricity because of some transformer problem is there. So okay, let's hope that this class will continue. So I will hope that this class will I will definitely try to continue this class, because maybe inverter will stop working because it is running from some from last number of hours. Okay, so this is all about me, beta. Okay, let me start the today's topic. Okay, this information I would like to share here, that new Unacademy is giving you the best offer, right? For few days, it is only for few days. Actually, it is for few numbers. I think some 1,000 subscriptions only. So this is a 20% off. In general, you are getting only 10% off. So you can see that this is the price list. If you are purchasing for 12 months, then you need to pay only 34,554 only, right? But this 20% off you will get if you are using code this one, SHIVAMDIXIT, sorry, Shivam 101, not full name, Shivam 10. Okay, that's it. So this is about mechanic. And even if someone is taking distance learning program, means Unacademy Lite, there also the same offer is there, 20% off, and you will get it for mechanical. 16 books are there, right? Distance learning program, you will get basically books, and that book you will get in what you have to pay for 8,754. 8,754 for 1 year, right? You will get test series, doubt clearing, all those things you will get. So this is basically Unacademy Live. Here also you have to use the same code Shivam 101. So okay, Rahini V, okay, good evening to all of you, beta. So whoever have joined, you have to like the session first, then you have to wish to your faculty, your friends, and after that immediately you have to go to your group, and there you have to mention that class is live. So this is the everyday procedure that you need to do. Okay, so in yesterday's class, beta, we have discussed about the surface tension. Basically, surface tension, what is the surface tension? I told you that suppose if you have some liquid, right? If you have some liquid, then whatever molecule is at surface that have net downward force, so but it is still not going down. Why? Because here some membrane is going to be formed. Here basically what is going to have happened, here some membrane is going to form. So this basically membrane, the formation of membrane is basically called as what? Surface tension, and is quantified in terms of per unit length. It is quantified in terms of per unit length में defined है. So एक लेंथ में जितना भी फोर्स लगेगा उसको हम लोग क्या बोलेंगे? सिग्मा डिफाइंड है. सिग्मा इज इक्वल टू एफ बाई एल. सिग्मा इज इक्वल टू एफ बाई एल मीन्स न्यूटन पर मीटर. ये डिफाइंड है, ये हमने आपको कल बताया. And because of this surface tension, this liquid droplet, or it may be bubble, it will always try to be spherical in shape. And the most important thing I told, that if any arbitrary shape is there, suppose whenever droplet is coming out or separated from the bulk of liquid, जो बल्क ऑफ लिक्विड है उससे अगर सेपरेट होता है तो क्या होगा, यहाँ पे देखो इस तरह से मॉलिक्यूल सरफेस पे रहते हैं, राइट, एंड दे आर कॉन्ट्रैक्टिंग लाइक दिस, दे आर अप्लाइंग फोर्स लाइक दिस, राइट। सो इससे क्या होगा, इंटरनल प्रेशर जो है, पहला चीज तो क्या है, ये स्फेरिकल शेप में आ जाएगा। जब ऐसे ऐसे मॉलिक्यूल रहेंगे then what will happen first, they will come to the spherical in shape. Okay, so this will become spherical in shape. This is the first conclusion. That this is going to be the spherical in shape, and here pressure will be somewhat more than atmospheric pressure. Let's say here pressure is P atm, and here pressure will be P atm plus delta P. So this excess pressure will be there inside a liquid droplet, or it may be bubble. Clear hai beta? This point is clear. So now here you can see all these diagrams, right? So in first diagram you can see that the small pin, right, a small pin can float in water even though it is a metallic. Why it can float? Because it is going to be resisted by the surface tension, right? ये surface tension की वजह से कर रही है, not because of Archimedes principle. Don't think that it is because of Archimedes principle, right? You may heard that this floating principle is given by Archimedes now, but this pin is floating because of the weight of the pin is so small that it can be sustained with the help of surface tension. Second thing I told that this droplet is going to be what? Spherical in shape. This droplet is going to be spherical in shape. Third point I told that if any arbitrary shape is there, then after some time it will come to the spherical shape because of surface tension. This small insect is crawling over water. Why? Because its weight is very, very small, and that weight is going to be balanced by the surface tension. Here also the same reason is there. Now one very important thing I am telling you that, right, if suppose if you are increasing the temperature, this surface tension will reduce. That's why if you are washing your clothes with warm water or hot water, then it will be easily washed. Why? Because then the formation of bubble, right, formation of droplet will be small, so that can penetrate easily. Now please listen here carefully. The size of water droplet or liquid droplet will be decided by the surface tension. If surface tension will be more, then more amount of or bigger amount of water droplet will be there. From here you can see that this is from initially, if you just look at the closely this टैब को अगर क्लोजली देखें तो पहले क्या होता है, छोटा सा राइट चिन्ना वाटर ड्रॉपलेट रहता है, उसमें क्या वाटर ऐड होता जा रहा है, वाटर मींस mg बढ़ता जा रहा है, बट इट इज नॉट गोइंग टू बी सेपरेटेड आउट, राइट? mg is increasing. After some time, when the mg will be more than the surface tension force, then what it will be separated, means who is going to balance that is surface tension, right? So the size of droplet will be decided by the surface tension. So mercury, in case of mercury, the surface tension is going to be the more, right? Mercury surface tension is basically what? That is more. So that's why if you look at the size will be somewhat bigger than water, right? Because we already know a value. If I tell you sigma, here I'll write sigma of H2O at 20 degrees temperature, because it is dependent upon the temperature. At 20 degrees centigrade, the value is 0.0736 Newton per meter. Clear hai? This is for H2O. Now sigma value of Hg, right, in normal temperatures it is 0.44 Newton per meter. You are getting my point now? So mercury surface tension is more, so mercury droplet will be big in size, because that surface tension can hold more mg. That point I already told you. Then one more thing I told you, that if you are adding detergent in the water, then you can wash the cloth easily. Why? Because if you are adding the detergent, that is basically decrease the surface tension. Scientific name is surfactant, right? So if you are adding detergent or surfactant, then what will happen? Its surface tension will reduce. If surface tension will reduce, then small droplets will be formed, and then it will penetrate the cloth easily and it will wash the cloth easily. Clear beta this point? Up to here clear? Acha, one more point I would like to share here, that is this. Okay, all these things I already discussed here, right? Notes I will give you. Now in last I told you that surface tension is basically due to unbalanced cohesive force. It is not because of cohesive force, it is because of unbalanced cohesive force. क्योंकि जो molecule अंदर है उसमें भी cohesive force है, but that is not creating any surface tension. Only the molecule that is surface have the downward force because of the cohesive, right? So it is unbalanced cohesive force, and with the increase of temperature, cohesive force will basically decrease, so surface tension will also decrease. Very simple logic is there. Okay, surfactant, detergent, I already told that this point. Now one more thing is there, that surface tension can also be defined in terms of surface energy. Surface tension can also be defined in terms of surface energy. This point you need to understand. Okay, now how many are there here? Good evening beta. Sir, you said only 40 hour for crash course, but already 11 are completed, but first chapter is not complete. If for not 40 hour, it will go for 50 hours basically. This is going to be a 50 hour, and initially I'm not that much comfortable with this YouTube and all, that's why it is taking somewhat more time. But don't worry, in future I will pick up my speed, I will increase my speed, and I will try to cover more things. And especially one thing I would like to tell you, Priyanka, that initial 5 chapters are very important. Initial 5 chapters are going to take more and more time. Later on it will be empirical formulas, basically application part is there, right? So that is going to take less time only, right? So don't worry. Power escape, it's too hot, yeah, it's too hot, thank God. So don't worry, I will try to complete within time only. And many students are right, don't worry people, I will definitely I will just switch off this fan, otherwise it will create noise. Just a minute. Don't worry, I will definitely complete this part as well as thermodynamics also before the GATE exam. As I told you, before the GATE exam I will definitely complete. Now one more thing beta, that many people are requesting me for thermodynamic question series. Thermodynamic question series, even I am going to do one for actually I am planning some special classes. So this month itself I am going to plan 10-hour special class. 10-hour special class, mean every day 1 hour I am going to plan. Sir, what you will teach in that one? I am going to teach the very most expected problem of thermodynamics. Most expected problem of thermodynamics. Not only problem, this will be concept through, question through, concepts through question series. This will be concept through question. So basically what I am going to say, suppose first chapter is there in thermodynamics, first chapter is there. So in first chapter only 3 things are there from which question may be formed. Only 3 concepts are there. Only 3 concepts are there. So I am not going to teach what is thermodynamics, what is application of thermodynamics, what is system, surrounding, boundary, equilibrium. No, I am not going to deal with all this. Only I will deal the part from which numerical problems are going to be formed. Just say in first chapter, the first statement through which question can be formed, that is properties are exact differential. So I will teach you that what do you mean by exact differential and what type of question can be framed. The second type of problem can be framed, that is based on the scales, the temperature scales, based on the temperature scales, zeroth law of thermodynamics. So that is based on scales. Then third problem can be framed with the properties of ideal gas, how to calculate the properties of mixture of ideal gas. So 3 type of question can be framed from first chapter. Now second chapter, in second chapter only one formula is there, right? right? That is W is equal to integration 1 to 2 PdV. Now on the basis of this formula, 4 type of problems can be formed. One is the area of the diagram, that is one type of question. Direct W is equal to integration 1 to P PdV when process is known. Another one is process is not known, equation is known. Another one is what? Piston cylinder arrangement, and it is going to rise. Okay, so that part is there. So only 4 type of problems are there in work in heat chapter. Then come to first law of thermodynamics. In first law of thermodynamics, first law for closed system, steady flow energy equation and unsteady flow energy equation. From closed system, again 5 type of problems will be there. Steady flow energy equation, 3 type of problems are there. Unsteady flow equation, only 2 type of problems I'll discuss. Even 1 type itself is enough. Correct. So like that I am going to solve. So in this 10 hours beta, I will try to complete the basic thermodynamics through like I will not teach concept directly. First I will show you the question. This is the question, right? This type of question, how to solve. So whatever concept behind this question, that I will tell you. Whatever concept behind this, that I will tell you. Key point I will tell you. Okay, so this is, but only one confusion I have. Only one confusion I have, beta. Only one confusion I have. What is that confusion? The confusion is, should I start from applied thermodynamics or basic thermodynamics? This is the doubt I have. Or this month I do basic thermodynamics first, and next month I will start applied thermodynamics. This is your choice. Now I want poll in this one. So tomorrow in our Telegram group, I hope you are there in Telegram group where you are getting all these notes and all. Shivam Dixit 63. So in that one, basically I am going to form a poll. In that poll you have to tell that which should start. In my opinion, in my personal opinion, I would like to share here that in this month we'll target for basic thermodynamics. Right, basic thermodynamics means basic concepts and heat and work, first law of thermodynamics, second law of thermodynamics, entropy and exergy. 5 topics are there. Every topic, even if it will take 2 days, every topic will take even 2 days, then also in 10 days we can kill the basic thermodynamics. Okay, then applied thermodynamics, again 5-6 topics are there, right? So that we can kill in next month, right? So in my opinion, basic thermodynamics will be done. And XC, don't worry, XC ke liye maha marathon I will run one maha marathon where all XC type of problems will be, because XC problem are somewhat level is high, right? Compared to mechanical, the XC problems are little bit higher, right? Higher one, right? Good number of problems are there. So you'll solve previous year, some previous year XC problems, as well as some questions from PK Naam, wall valence and Sengil. Karina, I will select some problem, that problem will solve, so that you will be, if someone is going to write the GATE exam, XC exam, someone is going to write XC exam through thermal and fluid, don't worry, मैं पूरा preparation करा के देगा, whatever will be required I will do it for you. Properties of pure substance भी करवा देंगे, don't worry. Properties of pure substance and only working fluid is different. All the formulas, everything is same. Okay, I'll do that part also, don't worry. Let's see, जितना भी हो पाएगा 10 दिन में, जितना भी 10 hours में हो पाएगा, right? That I will do basically. That I will do. Clear है? So even if you want, you can comment here that should I start basic thermodynamics? This is concept through question. Concept through question. Which वॉइस नहीं आ रही है? इज इट ट्रू? वॉइस नहीं आ रहा है क्या भाई? वॉइस नहीं आ रहा है क्या? प्लीज टेल मी. अमरजीत यादव इज सेइंग दैट वॉइस इज नॉट कमिंग. इज इट ट्रू? अरे आ तो रहा है, मुझे तो आ रहा है. Voice is clear. Okay, Amarjit, you check your laptop, you check your connection. No sir, we are hearing. Okay, so please comment once that what you want. You want applied thermodynamics question through like concept through question series, or you want basic thermodynamics? In my opinion, basic thermodynamics will be better. Next month applied thermodynamics, in my opinion. आज कोई match है क्या? Is there today is any match or something? Because very less people are there. Very less people are there, beta. Very less people are there. Basic thermodynamics. Okay, fine. बहुत कम लोग हैं, और जिसने भी लाइक नहीं किया तुरंत लाइक ठोको यार भाई, यही तो फीस है तुम्हारी बेसिक थर्मोडायनेमिक्स. ओके ओके, आई विल स्टार्ट विद द बेसिक थर्मोडायनेमिक्स. लेट्स सी. ओके, नाउ कम टू फ्लूइड मैकेनिक्स पार्ट बेटा. फर्स्ट कम टू फ्लूइड मैकेनिक्स पार्ट. ओके, सो मैंने क्या बोला कि सरफेस टेंशन is defined as a line force per unit length, but it can be defined in terms of surface energy also. Sir, I did not get it that how it is defined in terms of surface energy. Anyone knows about this? Right, sigma is equal to F into L. Everyone knows about this, right? But what about India is already gone to home, sir. क्या वो सेमीफाइनल में नहीं गया क्या इंडिया? मुझे नहीं पता, मैं मैच नहीं देखता हूँ यार. आई डोंट डू एनी अनप्रोडक्टिव थिंग्स. मैं सोता बहुत हूँ. मैं सो जाता नहीं. मुझसे कहते हो तुम मूवीज देख लो, है ना, मोबाइल देख लो, वीडियो देख लो, एंड यू नो मैच देख लो. सो आई विल बेटर प्रेफर टू स्लीप. मुझे सोने मतलब बहुत सोता हूँ मैं. बट आई पर्सनली फील दैट इज बेटर थिंग. मैं अभी क्लास के टाइम पे मोबाइल यूज करता हूँ, लैपटॉप यूज करता हूँ, और जो पीपीटी वगैरह बनाना होता है उस टाइम पे यूज करता हूँ. उसके अलावा कुछ नहीं. राइट, ओके. सो समझिए, now you need to understand that how surface tension is defined in terms of surface energy. Right, please listen here. Just you assume that one big droplet is there, one big water droplet is there, one big water droplet is there. Okay, now I'm breaking it. Now I'm breaking into number of pieces. Will there is any change in volume? No, volume will not change. What I'm trying to say, suppose this size of droplet is there. Now I'm breaking into 4 small parts, for example, 4 small parts. Okay, so the volume is not going to change. Whatever initial volume is, the same final volume will be there, because this is a law of conservation of mass. And here it is incompressible, so volume will also, now if it is gas then volume may change, but it is actually liquid, and we are dealing it as a incompressible. So what will happen if one big droplet is there, you are breaking into 4 droplets, then there will be no any change in volume. Now my question is, when you are going to break this big molecule or big droplet into small droplets, then you need to do some work. Without work it is not possible. Nothing is going to happen simply, right? Everything has some region, everything have required some energy and some potential, right? So अब इसको जब हम break करेंगे, if you want to break it, then obviously some amount of work you need to do. That may be very small, in 0.000 something, right? That work will be very small. That is fine, but work will be required. Now, according to law of conservation of energy, energy is neither created nor be destroyed. Only one form of energy converted into another form. जो आपने work किया, whatever energy you did, whatever work you did, where that work is gone? That is my question. You understand the question? Question is very simple, that if you have one droplet, a big droplet, in a liquid droplet, and just breaking into number of pieces, right? Then what will happen? then you need to do some work, but law of conservation of energy is there. Work, like whatever work is there, that is converted some other form. Energy neither created not be destroyed, only one form of energy can be converted to another form. Is whatever work we did, that is going to convert into some another form. So basically where that energy went, this is my question. आंसर करो फास्ट वालो जी. तुम लोग ना बहुत परेशान कर रहे मुझको, बहुत परेशान कर रही, कुछ जवाब नहीं देते, लाइक भी नहीं कर रही, शेयर भी नहीं कर रही, क्या कर. स्टोर्ड एज ए सरफेस एनर्जी, सुमित. इंक्रीज द सरफेस, ये संतोष मिश्रा, वेरी गुड. डोंट नो सर, बालाजी, वेरी गुड. बालाजी, very good. Now please listen here carefully. Please listen here carefully. Please listen here carefully. Actually, volume is not changing, but surface area is changing. Surface area is changing. What it means that? It means that in surface number of molecules are increasing. Surface area बढ़ जाएगा तो surface में molecule बढ़ जाएगा. So the surface energy, whatever work we are doing, whatever work we are supplying, that work is going in the surface energy. That work is going in a surface energy. So whatever surface area of this big droplet will be less compared to the surface area of these 4 small droplets, right? So surface area is increasing. So whatever work you are giving, that work is going to increase the surface area basically. So that's why we can define the sigma like this also. Sigma can be defined in terms of surface energy, that is work required to the by increase in surface area. इंक्रीज इन सरफेस एरिया. क्लियर है बेटा? फिर से देख लो. तो सरफेस टेंशन रिप्रेजेंट द अमाउंट ऑफ वर्क रिक्वायर्ड. सरफेस एरिया रिप्रेजेंट्स, not exactly it is defined as F by L only. Exactly it is defined as F by L only, but it is actually representing the amount of work to be done to increase the area of surface by unit amount. Area of surface by unit amount. Clear है बेटा? Any confusion? No confusion at all. So basically I can explain you in better way. Suppose this is the surface. This is surface, only for your understanding I'm telling you. This is surface, right? And in this surface I would say that this is, let's say, length L, right? And here I'm applying sigma. It is exposed surface. This is exposed surface, right? And sigma is going to be applied. So the increase in surface area is, let's say, something like this. Increase in surface area is something like this. Some surface area, this much surface area increases, right? Shape पे मत जाओ, only amount पे जाओ, only amount, right? So let's say it is stretched by delta x, or x distance I can say. So this is the increase in area. This is increase in surface area. Increase in surface area. So इसमें इस surface area को increase करने के लिए, to increase this much surface area, how much work is required? Work required from this formula, work is sigma into increase in area. Increase in area कितना आ रहा है? L into x. L into x. Or delta x you can write, because x is representing like it is a very big amount, right? So generally it is very, very small. So delta x. So this is W. So like that also you can represent. So W is equal to sigma into increase in surface area. Like that you can remember. This is nothing but increase in surface area. This is increase in surface area. Clear है बेटा? Clear है? चंदू, yes, चंपक, clear है? Now in last lecture I told you one more thing. Now itself also I told that if suppose liquid droplet is there, in that liquid droplet, internal pressure will be, inside pressure will be somewhat more than outside pressure. Why? Because of surface tension. Because of surface tension. This extra pressure is actually because of surface tension. Please listen here carefully. See, here pressure will be, let's say, PA. Here pressure is PA, so here pressure will be PA plus delta P. Now I want to find out what is this extra P, because this extra P is going to balance by surface tension. This extra P is going to balance by surface tension. Now P is pressure that is defined per unit area. Pressure is defined per unit area. And a surface tension is defined per unit length. Per unit length. Sir, kaise pata chalta? Very good. Do one thing. Just break this in two parts. Just break this in this droplet in two parts. When you break this in two parts, then how would it will be look like? It will be look like this one. It will be look like this one. Okay. Sir, please do thermodynamics also. Arey, don't worry, मैंने बोल दिया ना. If whoever is going to write XC paper by thermodynamics and fluid mechanics, just prepare maths, aptitude, English by your own. And whatever you studied in fluid mechanics, thermodynamics, just keep on revising. Whatever I am going to do, just follow me up to the gate. Just follow me up to gate exam, up to last day of gate. लास्ट डे तक प्रैक्टिस कराएगा मैं. लास्ट डे को भी मैं कराएगा प्रैक्टिस. वन डे बिफोर भी मैं प्रैक्टिस कराएगा. तो क्या है आपको, then you have to only follow me. Believe me, you are going to get very good practice series, number of practice series, question concept through question series, short term courses, practice sessions, maha marathons. All these things I will bring for you. All these things I bring for you. See, short term of fluid mechanics is going on. Let's say it is going to over in next month, right? Next month it is going to over, right? Then the practice session of fluid mechanics will start. Practice session of fluid mechanics will start, and thermodynamics short term course will start, right? And now what I'm going to do, now I'm going to concept through question, right? Concept through question series for thermodynamics. Once it will done, then fluid mechanics will also be done, right? Fluid short term will be done. Then this fluid mechanics I will revise in 10 days. Complete fluid mechanics I will revise in 10 days in concept through question series. When I discuss in concept through question series, then all these things I will directly come with questions. This is a question based on the excess pressure inside the liquid droplet. कैसे निकालना डायरेक्ट बताता, फॉर्मूला बताता. Let's go. Clear? Don't worry. थोड़ा मेरा साथ दो, मैं तो तुम्हारा साथ देने के लिए जिंदा हूं, अदरवाइज कब का मर गया होता. Okay. So now I am going to like cut this in two pieces. So one piece is look like this one, another piece will be look like this one. Right? This is the thing. Okay. So this bubble droplet I cut in two parts, right? Now cut in two parts. So what will happen, beta? See, we know that pressure is always act in area, normal area. Now please listen here carefully. That this is, let's say, diameter is D. This diameter is, let's say, D. This diameter is, let's say, D. Now PA and PA is going to be cancelled. Inside pressure, excess pressure is how much? Delta P, and that is only going to balance by surface tension. So as I am going to equate it by surface tension, then no need to consider PA, because PA will be cancelled out. So here what you will get, beta? Here basically delta P will be there. Delta P. Here delta P will act. And this delta P is going to balance by surface tension, and that surface tension will be a line force. It will act only at the surface, exposed surface. Okay. It is going to at line of the exposed surface, beta. जो एक्सपोज सरफेस है उसी पे लगेगा. बीच वाला पोर्शन तो जब, अरे ढक्कन तो मैंने एनालिसिस के लिए खोला है ना, उससे पहले तो बंद रहेगा ना. Correct. So here basically sigma is going to work, right? Now what I can do that. So whatever pressure for extra pressure force is there, whatever pressure force is there, that is going to balance by surface tension force. Pressure force is going to be balanced by surface tension force. Sir, what is pressure force? Very simple. What is delta P? Delta P can be written as Fp pressure force divided by pi by 4 d square, because ये किस पे लगता है? एरिया पे लगता है. Similarly if I write Fs, सिग्मा क्या था? सिग्मा इज इक्वल टू Fs बाई सरफेस एरिया, लाइक एल लेंथ इज हाउ मच? पाई डी पे लग रहा है ना. ये देखो, ये मैंने डायग्राम बनाया क्या है? पाई डी है. सो दैट विल बी पाई डी. सो Fs value will come sigma into pi into d. Now this is one equation, this is two equation. Now put this value here. Now put this value here, means this excess pressure is going to balance by surface tension. So now I can have sigma pi d is equal to Fp value will come, sorry, this side I will write Fp value will come delta P into pi by 4 d square is equal to Fs value sigma pi d. Now कुछ कट पिट रहा होगा, देखो कुछ कट पिट रहा है. यस, पाई से पाई कैंसिल, एक डी से एक डी कैंसिल. So delta P value you will get how much? Delta P value you are going to get 4 sigma by d. 4 sigma by d. This is the excess pressure inside the liquid droplet. इसमें किसी को प्रॉब्लम है, कुछ कंफ्यूजन है, बता दो. इसमें किसी को प्रॉब्लम है, कुछ भी प्रॉब्लम है, कुछ भी चीज पूछना है पूछ लो. सबको समझ में आया? आदर्श बोलिए. आदर्श, अमरजीत यादव, किरण, कल्याण, दत्ता, प्रियंका, प्रदीप साईं, दामोदरन, राहिनी. वेरी गुड. क्लियर है बेटा? Now this is about the liquid droplet, but in case of bubble, soap bubble, suppose soap bubble is there. In case of soap bubble, more pressure will be there. In soap bubble, more pressure will be there. Why? Because surface area, two surfaces are there. In soap bubble, two surfaces are there. Two surfaces that mean more surface tension is there. So more surface tension is there means it can hold more amount of pressure. Sir, direction वाला please repeat कर दीजिए. डायरेक्शन वाला क्या रिपीट करना? देखो, हमको बेसिकली देखना है कि किस एरिया पे लग रहा है. ये हमारा लिक्विड ड्रॉपलेट है. देखने के लिए हमने क्या किया? इसको कट कर दिया तो सिर्फ हम एक्सेस प्रेशर ले रहे हैं, राइट. सो एक्सेस प्रेशर किस पे लगेगा? एक्सेस प्रेशर लगेगा सरफेस एरिया पे, राइट. और जो उसको बैलेंस कौन करेगा? सरफेस टेंशन. जो किस पे लगेगा? वो पेरीफेरी पे लगेगा. तो जो प्रेशर फोर्स है उसको सरफेस टेंशन फोर्स के बराबर कर दिया. आगे आंसर आपके सामने. अगर बबल है फॉर एग्जांपल, राइट, बबल के केस में पहले मैं बता देता हूं, राइट. यहां के लिखूंगा तो छुप तो नहीं जाएगा मेरे पीछे. फॉर सोप बबल, now what is going to happen? Two surfaces will be there. Like if you cut na soap bubble, अगर सोप बबल को कट करते तो कैसा दिखता वो? it is one surface here, right, and inside also one surface will be there because some thickness रहेगा ना उसका, some thickness रहेगा वो कोई, it will be something like this. ऐसे कुछ दिखेगा, right. Now in this case the surface tension is going to act like this. ऐसा लगेगा. So now in case of soap bubble, the Fs will be 2 pi d, means it will be like delta P into pi by 4. Same formula I am going to use here. Fp is equal to Fs. So Fp value equal to delta P into pi by 4 d square is equal to sigma into 2 pi d will come. 2 pi d. दो सरफेस ना, 2 pi d will come. So from here, if you calculate delta P value, you will get 8 sigma by D. 8 sigma by D. 8 sigma by D. Clear hai? For soap bubble, liquid droplet 4 sigma by D. Liquid droplets 4 sigma by D. And for this one, 8 sigma by D. हाँ वही यार. क्लियर है बेटा? Shall I reach the next? Now next one is excess pressure inside the liquid jet. अब देखिए, number of places we have seen that jet is coming out like this. Suppose number of places we have seen that jet is coming like this, right? Jet is coming something like this. This is a jet. This is jet, right? So jet is basically cylindrical in shape, right? Cylindrical in shape we can consider here, right? So now to understand the concept, what I'm doing is I am cut down from this one, right? This portion I'm going to cut down. I'm going to take it out. This portion I'm going to take it out. When I'm going to take it out, then it will be something like this. Clear hai? Take it. Now I'm going to cut it, right? I'm same like liquid droplet. Same like liquid droplet, I'm going to cut it. When I'll cut it, then how it will be look like? It will be look like this one. Now in this one, delta P is going to act as a delta P will be act as at a surface area, this cross section area, and sigma will act somewhere here. Let's say this length is L, this is D. Now please listen here carefully. Please listen here carefully that okay, first I'll write the equation, then I'll tell you one doubt. Most of the students have that doubt. Most of the students have that doubt. Okay, now here I can write FP is equal to Fs. FP is equal to Fs. Now FP value will come how much? Delta P, and it will act at the surface area, right? It is going to act at a surface, it will going to add a cross section area. Now cross section area will be L into D. Cross section area will be L into D. Clear है? ये क्या आ जाएगा? L into D. Now Fs value will come how much? Fs value sigma is equal to Fs by surface area where it is going. L means length. Now it is going to be 2L. अरे ये एक L हो गया, ये दूसरा L हो गया. So this will come sigma into 2 into L. Now L cancel out. L cancel out. So you will get delta P value as a 2 sigma by D. Now one confusion. Most of the students have one confusion that sir, why you did not consider this surface also? Here also it will act na. Like many of students are thinking that here also it will be something like this, right? But it is not like this, beta. Please listen here carefully. It is not like this. It is not like this. Why? I will tell you. Because that is not going to be exposed surface. अरे इधर देखो ना, ये पोर्शन, ये वाला पोर्शन तो exposed है ही नहीं ना. ये तो jet का part है ना. That is a part of jet. That is a part of jet. In most of the book, what they are writing, that neglecting this D. D is very small compared to L. D is very small compared to L. That's why we are neglecting it. But no, This is not the correct region. The correct region, only few standard books if you read, then only you are going to get that this is a part of jet. अब जेट में ये एक्सपोज एरिया सरफेस तो है ही नहीं ना. जब पूरा पूरा जेट देखेंगे वो तो हमने यूनिट लेंथ बाहर निकाल लिया या सम लेंथ बाहर निकाल लिया है, बट एक्चुअल तो पूरा क्या है, पूरा का पूरा ये जेट है. तो जेट में एक्सपोज सरफेस, ये वाला जो सरफेस है वो एक्सपोज सरफेस पे नहीं आएगा. समझ में आया? क्लियर है? यही एक्सपोज सरफेस में आएगा जब हम कट करके क्रॉस सेक्शन पे देखेंगे. तो दैट इज द ओनली रिस्पॉन्सिबल बेसिकली, दैट्स इनसाइड. यस रायू, रायू जे आर. क्लियर बेटा? So I hope that you understand all these concepts. Now we'll solve some problems. Oh, battery is about to go. Battery. क्लियर है? सबको सब कुछ क्लियर है? Everyone, let's solve few problem on this. Let's solve some problem on this surface tension. The very first problem is in front of you. Tell me the answer fast. Tell me the answer fast बेटा. दिख रहा है क्वेश्चन? Can you see the question बेटा? क्वेश्चन दिख रहा है? ये ESE 2008 में पूछा गया है. This question is being asked in GATE ESE 2008. What is the pressure inside a soap bubble? Soap bubble over atmospheric pressure. मतलब क्या पूछ रहा है? It means that it is asking excess pressure. What is the pressure inside the soap bubble? Soap bubble over atmospheric pressure. If it is diameter is 2 centimeter and the surface area is also, surface tension is also given. So for soap bubble, what was the formula? Delta P, actually you need to find that is 8 sigma by D. 8 sigma by D. So 8 into sigma value 0.1 and D 2 centimeter hai, right? So convert into meters, so 0.02. So I think how much it will come? 40. How much it is coming? 0.4 is coming, huh? Rayu junior NTR. 40 Newton per meter square. सॉरी कैलकुलेशन में से ऐसा कैलकुलेशन मिस्टेक एग्जाम में किया तो समझ लेना मैं क्या करता. सारा कॉन्सेप्ट आता है, कैलकुलेशन मिस्टेक कर दिया, देन व्हाट विल हैपन? देन यू विल गेट हाउ मेनी मार्क्स? नॉट 0 मार्क्स, यू विल गेट नेगेटिव मार्क्स. नेगेटिव मार्क्स मिलता. कैलकुलेशन मिस्टेक इज नॉट परमिटेड in exam hall. Okay, let's solve the next problem. Okay, please try to solve this problem. Please try to solve this problem. A small droplet of water at 20 degrees centigrade has a diameter of 0.05 mm. If the pressure within the droplet is 0.6 kilopascal, higher than atmosphere, means delta P value is given, then find the surface tension. So it is a small droplet of water. Droplet of water means delta P is equal to 4 sigma by D. Now this value is given 0.6 kilopascal, right in pascal, 10 to the power 3 is equal to 4 sigma. We need to find out. D value is given 0.05 mm, means 10 to the power minus 3. Tell me what is the value? So sigma value, I think you will get a 7. Tell me how much you are getting. Tell me how much you are getting. Sigma value. How much you are getting sigma value? I think 7.5 into 10 to the power minus 3. Check, is it correct or wrong? This is the answer given. I think so, it's correct only. Sir, during taking correction of bubble, we cut horizontally to calculate the surface area, but while taking the jet, we get longitudinal. अरे बिकॉज यू नीड टू सी दैट ना बेटा. आप देखो जो जो जेट है राइट. सो जो एक्सपोज्ड सरफेस है ना, एक्सपोज सरफेस, उसके क्रॉस सेक्शन को देखना है. ऐसे कट करना है कि उसका क्रॉस सेक्शन दिखे. और ड्रॉपलेट में तो फर्क ही नहीं पड़ता भाई. ड्रॉपलेट में आइदर यू कट लाइक दिस और यू कट लाइक दिस, इट्स सेम थिंग. नो, ड्रॉपलेट में तो कोई फर्क नहीं पड़ता. ड्रॉपलेट एंड सोप बबल में वेदर यू कट लाइक दिस or you cut like this, it will look like same. It will look like same only na. Clear है बालाजी? बालाजी, अब ये जेट है राइट. सपोज दिस इज अ जेट राइट. If you cut like this, then how this complete exposed surface is going to be, पूरा जो exposed surface है, in that surface the surface tension is going to act ना. So if you want to look the effect of this, then obviously you have to cut this longitudinal only. Next question. Solve this problem. Solve this problem. Solve this problem. यार मेरे मोबाइल में मैंने हाई पिक्चर क्वालिटी कर रखा है, बट स्टिल आई एम नॉट एबल टू रीड द प्रॉब्लम राइट. आई डोंट नो, ब्लर आ रहा है इन माय मोबाइल. मेरा इंटरनेट इज स्लो, आई थिंक सो. माय इंटरनेट इज स्लो, आई थिंक सो. So how many of you watched that Brahmastra movie? How it is? How is the Brahmastra movie? How is that movie? How many of you watched that movie? Don't watch. Rayu Junior, listen here. It was a tricky question. Why you watch that movie? Is it the time to watch the movies? You are preparing for GATE, na? Don't watch any movie, any web series, anything. Don't watch. It was a tricky question. I just want to know how many of you watched that movie. Okay, solve this problem. So please listen here that the spherical water drop of radius r. So the radius is r is split into air in n small number of pieces. Okay. And then find the work done. What is work done value? Work done is sigma into increase in surface area. Sigma into increase in surface area. This is one very important type of problem. 3-star problem beta. Now listen here. First we have to balance the volume. Is volume of large droplet. Large drop is equal to volume of a small drop into n. into n. Correct na beta? So this value will come. What is the formula for volume? 4 by 3 pi r cube. 4 by 3 pi r cube, and here it will come n times of 4 by 3 pi r cube. Small r. Small r is the the radius of a small drop basically, right? So here 4 by 3 cancel, pi r cancel. So r value will come capital R by n to the power 1 by 3, right? Now we have to calculate the work, right? What is work value? Work is sigma into increase in surface area. Now what is the increase in surface area beta? Sigma. So first you calculate the surface area of n small drops, right? So for one small drop, what is the surface area? Surface area 4 pi r square. So 4 pi r square, small r square, 4 pi r square, and I am going to multiply with n. I am going to multiply with n minus surface area of big drop, large drop. So that is 4 pi r square. So 4 pi will be common. So here I'll get 4 pi sigma. Here in place of r square, in place of r I can write capital R by n to the power 1 by 3. So it will come like r square by n to the power 2 by 3, right? Minus how much? R square. So finally I am writing here with another color. I am writing. Finally I am going to write here like what should I write? W is equal to 4 pi sigma r square. Also I'll take common. So here it will come n. Here n is also there, na? Yes, n is also there. So n by n to the power 2 by 3. So it will go up. So minus 2 by 3 means 1 by 3 it will become. So n to the power 1 by 3 minus 1. So this is basically the answer. क्लियर है बेटा? क्लियर है सर? is this type of question will come directly like where this formula we have to prove? No, actual problem will be maybe somewhat different. Actual problem may be somewhat different. How the actual problem will be look like, that I am going to discuss here. This problem is done बेटा. आ रहे हैं, जा रहे हैं, खाला का घर है, जिसको देखो आता जा रहा है, जाता जा रहा है. Yes. Now, what type of question can be asked exactly in GATE? That is this type basically. Now you solve this problem. Now you solve this problem. Now you solve this problem. Everyone solve this problem. Solve करिए जी. मेरा क्या चेहरा देख रहा है? Just wait for 1-2 more months. My beard will be like Arjun Reddy, Kabir Singh. Arjun Reddy. Done. This problem you solve beta. Datta Paul Mandal, Manoj Kumar Entertainment, Rayu Balaji D, Aishwarya, Santosh Mishra, Adarsh, Manigod, Kalyan, Shantanu. जल्दी जल्दी सॉल्व करो भाई, जल्दी जल्दी सॉल्व करो. जल्दी जल्दी सॉल्व करो भैया। अरे डन, तो आंसर बताइए ना नजीर भाई। नजीर भाई टेल मी द आंसर बी। नजीर भाई टेल मी द आंसर। दत्ता टेल मी द आंसर। पॉल मोंडल। Yes, Balaji, very good. Yes, Mondal. So this is very simple problem. Just now we seen that W value will come like 4 pi sigma r square, small r square into n to the power 1 by 3 minus 1. Just put the value 4 pi sigma value, how much given? 0.073 r. Now here you need to put attention. This is given in 1 mm, but is a diameter, and here is a radius. So radius will come 0.05. So 0.05 square, but convert into meter. When you convert into meter, then 10 to the power minus 3, but square, so 10 to the power minus 6. Then here 64 to the power 1 by 3 means it will come 4. This 4 minus 1, so 3. If you solve this, I think you will get 6.9 into 10 to the power minus 6 joule. Very small work. Very small work. You can see it's a very small work. 0.69 into 10 to the power minus 6 joule. Clear hai? Shall I move to the next topic? Mondal, Felix Wankel was a very great scientist, and he designed one rotary IC engine, that is also called a Wankel engine. A rotary IC engine which have very high RPM. It can go means like whatever vehicles you are seeing nowadays. If you want to increase the speed, if you want to increase the RPM, that's very difficult with reciprocating engines. But rotary engine is very easy. Clear beta? Okay. Let's move to the next one. Next topic, that is capillarity. Now I am going to talk about the next topic, that is capillarity, and this is the last topic in this particular chapter. And like after this I will move to the next topic. From this, okay, it taken somewhat more time, I can understand, but later on I will try to do the fast way, right? Later on I will do the somewhat fast manner. Now here, to understand the capillarity beta, capillarity rise is also there, capillarity fall is also there. So you need to understand what is this capillarity rise, what is this capillarity fall. It is very easy. You have to do one small experiment. Just take water, right, and just take a mercury. Just take a water and just take a mercury and put into the floor. Then you will see that whenever you are going to put into the floor beta, then water will come something like this. Okay, water will be some means it will ये फैल जाएगा, right? It will wet the surface. It will basically wet the surface, correct? It will basically wet the surface. Why? I'll tell you. Whereas mercury, how the mercury will be look like? Mercury will be look like this one. somewhat. Mercury will be look like this one, right? Now why it is happening? Because in this particular case here I would like to write that is, see, in case of water, cohesion is less, adhesion is basically more. Means I can say that adhesion is more, and here I can write cohesion is more. Please listen here carefully. In case of water, this is a water basically. I am writing here that is, there is a water, and this is mercury Hg. There is a water and this is a mercury. Please listen here carefully. What is cohesive force? Cohesive force, the attraction between the similar type of molecules, right? And adhesion is basically the like attraction between two different type of molecules. देखो इस वाले केस में क्या है? फर्स्ट केस में, इन फर्स्ट केस surface is a girlfriend of water. Surface is a girlfriend of a water. Whereas surface is a wife of mercury. Now you can understand, I think, right? Surface क्या है? Surface is the girlfriend of water. So what is happening basically, you know, right? So वो surface area बढ़ाना, चिपकना चाहता है, right? क्या करना चाहता है? ज्यादा से ज्यादा चिपकना चाहता है. You are understanding this point, right? Because you are understanding this point, right? So ज्यादा जब, बट जहाँ पे वाइफ की बात आ जाती, क्या है? वो अपने में ही मजे में, मैं भैया तुम दूर मैं दूर, कोई मतलब नहीं है. Clear this point? So attraction is basically less here. See here, this is the this is mercury and this is the surface. This is mercury and surface. Now this is basically what, here and here the attraction is less. Wife and attraction is less, but here attraction is more. That's why I try to cover more and more area. Correct? So why? Because adhesion is basically more here. So water molecule is more strongly attached with the surface, whereas in case of mercury molecules are attached with themselves, right? So that's why they are, it is called as what? Wetting liquid. It is called as what? Wetting liquid. And this is non-wetting liquid. हम देख रहे हैं तुम्हारा मॉडल, मजा आ गया? मॉडल को बहुत मजा आया है. शांतनु मॉडल, बहुत मजा आया तुमको है? Now here, what is the character? How we will get to know? Very simple thing is there. What is this angle of contact? Now to understand the capillarity, you must understand what is the angle of contact. If it is the angle made by the tangent to the liquid surface at the point of the contact with the solid surface. So that angle basically we need to find, that too also in anti-clockwise direction. Always it is measured in a anti-clockwise direction. See, the angle of contact always measured on liquid side. Basically means here if you want to measure the angle of contact, beta, here if you want to measure angle of contact, then at the surface, at the surface point of contact, this is the point of contact. Here you have to draw one tangent. Clear है? यहाँ पे एक tangent draw करेंगे, right? From liquid side anti-clockwise direction में क्या करेंगे? एक angle draw करेंगे, theta. Now this theta is called as what? Angle of contact. Similarly, this is the point of contact. Here I will draw one angle, and then from liquid side, this is theta, this angle. So now here you can say that theta value is always less than 90 degree. For wetting liquids, theta will be, angle of contact will be always less than 90. This question was asked in ESC. For wetting liquid, what is the criteria and also that criteria you can use here. Now here theta value will be greater than 90 degree. Clear है बेटा? क्लियर है? एनीवन? सर मैम आपका लेक्चर नहीं देखी क्या? नहीं नहीं नहीं, मैं पूरा पहले ही बोल चुका हूं. आई ऑलरेडी told her that if you want happy marriage life then never watch my lectures. I told that never watch my lectures. If you watch my lectures it will be unnecessarily problem for us only. So she is fine with that. She is never watching. वो उसको मेरा फेस देखना अच्छा नहीं लगता. So that's why she is never watch my lectures. Yes, correct. Clear at this point? Now you can see that now this point is clear, this point is clear. Okay, now come to the capillarity. Now what I am going to do is, again I am going to do an experiment, that I am going to take two containers here. I am going to take two containers here, right? One is this one and one is another one. Similar type of example experiment which I already did. So here we have water, here we have water, here we have mercury at G. Please listen here. Now here I am putting one very small diameter. If it is not small diameter, then you will not able to see the deflection. So why, I will get to know, you will get to know. So very small diameter, let's say less than 1 mm diameter or less than 10 mm diameter, I am putting one. Sir, PSU requirement, okay. I am putting very small diameter tube. I am putting very small diameter tube. ठीक है? Now what I will observe, right? What I will observe, if I am putting here very small diameter of tube, then what I will observe that the water is going to be rise. Water is going to be rise. Whereas if I put the similar type of tube, right, in mercury, then it will go down. Basically what is going to happen, beta, this is going to be rise. It will be something like this. So actually it will be not look good, right? It is difficult to understand. That's why I am actually going to put here a somewhat big size, right? I am going to, actually it is a very small size. Actually it is very small size. Just I am showing it in zoom. मैंने zoom कर दिया. Tube जो small tube था ना, उसको zoom कर दिया, right? Then it will be something like this. It is something like this. ये water level है, right? Now it will rise, and when it will rise, basically then it will be something like this. Q. Why it will be something like this, I will let you know, right? Similarly here if I do, right, here if I do, then tube is big size tube. I'm going to draw. So it will be something like this. So here you can see that in first case, water case, you can see that here this is height, this H is basically rise. Here you can see that it is a drop. It is basically a drop. So this rise and fall of liquid when a small diameter tube is immersed in it, called as what? Capillarity. Then it is called as what? Capillarity, that you already know. Now you can see that the capillarity rise is because of adhesive force, right? Capillarity rise is because of adhesive force, whereas capillarity fall is because of coercive force. Capillarity fall is because of coercive force. This point is clear. Now another point, why it is happening, is very simple logic. Water try to cover more and more area of tube. So क्या कर रहा, ऊपर भी जाके cover करने की कोशिश कर रहा है, right? but mercury wants to cover less and less area. कम से कम चिपकना चाह रहा है ये, right? ये ज्यादा से ज्यादा चिपकना चाह रहा है. That is the only difference. Now here if I talk about the angle of contact, if I talk about the angle of contact here, right? So what I need to do is I need to draw here at the joining here. I have to draw one tangent. Some other color I am using. Here I will draw like this. And from this surface, tube surface, I am going to measure, that is theta. So this is basically theta. And here if I draw theta. Clear है बेटा? This point is clear. Any confusion? No confusion at all, right? No confusion at all. This shape जो shape बन रहा है ना ऊपर या फिर ऐसे जो shape बन रहा है, this shape is basically is called as meniscus. That is called as what? Meniscus. Correct na? So that is one terminology, but not required for you. Now this strength of, please listen here this point carefully, the strength of capillary effect, the strength of capillary effect is measured by this angle of contact, that is theta. Angle of contact, that is theta. How? That I will get to know. So up to here, any problem? No problem. Is it meniscus? Now please listen here one more point. Now as I told you, the strength of capillary effect quantify by the contact angle, which is defined, a contact angle which is defined as the angle that tangent to be liquid surface makes with the solid surface at the point of the contact. At the point of contact में क्या किया? Tangent draw किया और जो ट्यूब का सरफेस है वहां से एंटी क्लॉकवाइज डायरेक्शन या फिर ट्यूब सरफेस से हमने उसका टेंजेंट का एंगल मेजर कर लिया. दैट एंगल इज बेसिकली एंगल ऑफ contact. Clear है this point? Clear this point? Okay. Now I am going to find out, this is the only thing that is required for gate point of view. For gate point of view, whatever thing is there, this is the only thing that is required, that which is a capillarity rise or fall. For both same formula is there. Only theta will change. So one value will come in positive, one value will come negative. Just wait. So expression for capillary rise or fall, right? So this will be something like this. So suppose here we have surface. Clear hai? Here let's say water, for example I am considering it as a water here, water. So if water is there, then what will happen? Basically it will go something like this. It will go something like this, right? This angle is theta, I told you. Same here also, theta. Clear beta this point? Now this height is h. So whatever amount of water is lifted, that is actually balanced by the surface tension. That is actually balanced by the surface tension force. Please listen here this point carefully. This is basically relative concept. See, whatever, because this mg, whatever mg is there, that mg is going to balance by surface tension only. So this here I can write sigma. So basically I can say that if I take this portion out, if I take this portion, whatever portion is lifted, if I take this portion out, then it will come something like this. Now meniscus I am not drawing because that is not required, because okay, that I know that this is going to act like this, sigma is going to act like this, sigma. Otherwise you will confuse that, sir, how you are taking the area and volume or something. Or you can think of that, okay, it is something like this only, right? It is something like that. Clear hai? No problem. Now here you can see that sigma is acting like this. So one component of surface tension will be in vertical direction and mg will act at here, mg or weight. Weight is acting downward. Weight is acting downward. This weight is going to be balanced by sigma. Weight is going to balance by surface tension, but sigma is in this direction. So vertical component of sigma, correct now? So this weight, we already discussed about specific weight. What is specific weight? Small w. Specific weight is weight per unit volume, right? Or I can say weight is equal to specific weight. Weight is equal to specific weight into pi by 4 d square, okay, d square into h. Now this height is basically h and this tube diameter is small d. Pi by 4 d square into h, right? So this is basically volume. Oh, thoda sa shape pe mat jao, that is negligibly small, so that we are not considering. So weight is equal to specific weight pi by 4 d square into h. Now if I calculate this, equation number 1. Now if I calculate sigma, sigma is equal to what? Surface tension force by area, length. So surface tension force value will come how much? Sigma into L. Now it will act on pi d, periphery. It will act on the periphery. It will act on the periphery, right? So this will be pi into d. Pi into d. Now please listen here carefully. Who is going to this equation number 2? Now this weight is going to be balanced by like horizontal, like from this side if you see, because angle is measured like this na. So cos component of this. So I can say that this is fs cos theta. Fs cos theta. Now just put the value. So specific weight, that is mg, to pi by 4 d square into h is equal to sigma pi d cos theta. So 1d is cancel, right? 1d is cancel, pi cancel, correct? Now h, we need to find what is h value. H value will come 4 sigma cos theta, 4 sigma cos theta by omega w into d, by w into d. This is the formula. Clear hai? Up to here it is clear or wrong, right? Up to here clear or wrong? Any problem? Tell me beta. Up to any problem? सर ने रिप्लाई नहीं किया, क्या था यार? मैम आपका लेक्चर देते हैं ट्यूब, राइज फॉल कोसिव, it's a bad attitude for what? I'm not telling to my wife, huh? Tangential. Clear up to here? Any problem? Tell me. Any problem? Tell me beta. Any problem? Tell me. Clear? Okay. So this is about the first chapter. So first chapter is basically over, right? First chapter is basically over. Complete notes for first chapter I will share in the group. Don't worry, right? Complete notes I am going to share in the group. So you can go, you can take that notes and solve some more problems on this. Solve some more problem on this. Okay. Okay. Now please listen here one more point. Please listen here one more point. In last, so today's class is finished. Tomorrow we'll start the fluid static. Tomorrow we are going to start the fluid static beta. Tomorrow we are going to start the fluid static. ठीक है, fluid static start करेंगे, right? Tomorrow we'll start the fluid static. First we'll start with pressure. What is the pressure? What is hydrostatic law? Pascal's law. I'm damn sure you must have lot of confusion in that topic. How to measure the pressure? What are the devices like manometer, piezometer, barometer, single column manometer? Why we are using this? All these things, differential manometers, and then different pressure gauges are there, pressure sensors are there. Every single thing we are going to discuss here. Yes, और क्वेश्चन भी प्रोवाइड करेंगे. आई एम गोइंग टू प्रोवाइड वन शीट ऑल्सो. I am going to provide one practice sheet also that you need to solve. I am going to provide the practice sheet also. Okay. So in last, I would like to give you one information, same like previous days, that one vision batch is started at 8th September, right? 8th September, heat transfer is going on by Praveen Kulkarni sir, right? So heat transfer is going on, and my subject of fluid mechanics complete course. This is basically short term course, so a few of concept I'm dealing with very fast manner, but it's still taking too much time. But I will try to decrease this time. I will try to cover more concept in less time. So 22nd onwards, fluid mechanics is going to start in plus platform. Fluid mechanics is going to start. So if you want to take subscription for this batch, or even if you want to study your self study or any other batch, then you can take the subscription. And currently a very big discount is going on. 20% discount is going on. 20% discount is going on, and this 20% discount you will get on this particular code SHIVAM101, right? 20% discount is going on, correct? So this 20% discount you will get in this particular code. Okay, fine. So here either you can take plus subscription or iconic subscription, right? So basically in plus you will get top educator digital note test series, whereas in iconic you are going to get printed notes, special doubt clearing sessions, live mentorship, right? One person will be allotted to you who will look at all your problems. Sir, आप more question provide करेंगे? Yes. Then this is the difference in the price of plus and iconic. You can see that if you are taking 12 months subscription, then in plus it will cost only 3,599. But even in this also 20% discount you will get if you are using this particular code. And in case of iconic, the price will be 4,417. Here also you will get 20% discount if you are using this particular code. So this is the difference in plus and iconic. And even if you have some problem of money, you can go for EMI options also. Then here 20%. This is the latest thing, and this is only for limited period offer. This is for limited period, or it is for only valid for some subscriptions. Once that level will be par, right, that will be crossed, then after that there will be no any further one. So code आपको पता है SHIVAM101. Okay, so this is all about this. Now you can ask me any doubt if you have. You can ask. I have still 10 minutes for you. Still 10 minutes are there. You can ask me. You can ask me whatever you want. Thank you, beta. Thank you. What is the name? What is your name? I can't read Telugu actually. What is your name? What is your name by Telugu? I cannot read. Thank you. Thank you, Adit Paul. Thank you, Adarsh. So first topic is over. First chapter is over. Tomorrow onwards, I am going to start pressure and its measurement, hydrostatic forces, then buoyancy, flotation, right? And after that, one very important topic, that is relative equilibrium, right? Fluid in relative equilibrium, that also I am going to discuss. Kumar, okay, your name is Kumar, okay, fine. Kiran Mati, hi Shivam sir, great to hear you again, long time. I'm Kiran from 2017 batch ACE Academy. Okay, hope you are doing. From your batch itself, one student met me few days back. AIR 53. Okay. Okay. So we'll meet tomorrow at 7 p.m. Tomorrow we are going to meet at 7 p.m. Okay. Tomorrow we are going to meet 7 p.m. Okay, fine. Let's meet tomorrow 7 p.m. Kiran Mati, today is no special class, beta. Today is no special class. Balaji D, today is no any special class. Kiran Mati, so where you are there, like currently working? Are you working or doing something? Any other doubt if you have? Thank you, Balaji. Okay, done. Okay, so let's stop here. Now I'm going to stop here. So Thermor FM will be completed by before GATE. Don't worry. Like even I'll try to complete before 15 Jan. Before 15 Jan. All the practice sessions also complete. Short term course will also complete. As well as what you call a concept through question series will also complete. Everything will complete before 15 Jan. If you are writing XC paper with fluid mechanics and thermodynamics, then only you have to take care of mathematics and aptitude. I am working now. Thanks for asking. Okay, Kiran, great. Okay, so let's stop, beta.